Hello everyone and welcome to our next video. If it's your first time dropping in a video, just to give you some context, we are in the process of developing a social media app, but based on microservices. And our main goal here is to learn as much as we can about the patterns and about the problems that come with microservices and some of the possible solutions that are out there for us. In the previous video, we started the implementation of hashing the user password once the user signs up to our social media application, right? So just to give a more general idea, we are developing the sign up route in our authentication service, and we are in the process of hashing and saving the password. We are adopting a test-driven development approach, which means that we are always writing the tests first, or 90% of the times writing the tests first, and trying to come up with as many meaningful tests as we can. And then once the tests are failing, which is the case here, as you can see in the bottom, we are going to the production code, to the source code, and we are programming the functionality so that the tests pass. We sometimes go a little bit beyond just passing the tests, but most of the times we try to stick with the principle that production code should be enough and not more than the necessary code in order for our tests to pass. This also forces us to think about our business requirements in terms of unit tests and in the future integration tests and end-to-end tests. And as such, I think this also helps us structure the application in a much more straightforward way. So in the last video, we wrote a couple of tests for the password, right? We wrote a few tests to test if the sign-up route encrypts the password. But as it turns out, since we decided that encryption of password should be done at a model level, right? So this should be done here. Then we also wrote a couple of tests for our user, and these are more precise tests about the password, right? Maybe here we should also check that I would expect my new user.password, or let's do it like this. Okay, I will postpone this test a little bit. This is the test to check, right? I would like to check if both passwords are the same. What do I mean by that? If by hashing the provided password or by dehashing the stored password, I can achieve the original password. So how are we going to do that? There are many approaches, but there is one in particular that I really like for this kind of things, and it is for us to have a single class which is responsible for handling password related logic. So if I use a more formal term, this would be the singleton design pattern, right? That is, maybe you heard of it, but it's one class that is responsible to implement all the functionality related to password. Now, this is perhaps we will not do exactly as the singleton pattern suggests. We will simply implement a class which has static methods. What does that mean? So static methods are methods that belong to a class and not to an instance of the class, right? So if I have, for example, a class that has a method that is not static, I need to first instantiate that class, and then I can call the method of that instance. If I want to access this method somewhere else, I need to instantiate the class again, and the methods of these two instantiated classes, so these methods of these two different objects, they are going to be different methods. They are going to be within the scope of those objects. But if I have static method, this method is the same for all the instances of the objects or of the class. So for all the instances of that class, right? They don't belong to any particular instance. They are attached to the class itself. And this makes it much easier for us to have a single place where we can, for example, hash and compare passwords, right? So we will do that by adding a folder here that is going to be called utils, maybe. Yeah? This is going to host, for the moment, a couple of shared responsibilities or classes that are not specific to a single route or specific to a single error. They can be used in many parts of the application. This will probably be removed in the future. This will probably go to a package that we will develop soon, which is going to host all the code that is shared among several services. So probably this password class that we will create, it will also go into that folder. But for now, because we are not yet thinking about how to share and centralize code in our application, we are focusing on the functionality of the authentication microservice, and more specifically the sign up functionality. We will create this class within the auth folder, right? So how can we work with this static way of thinking things, right? So the idea here is that it's very simple. I will just export a class called PasswordHash, and this class is going to have a static method. And this static method is then going to be shared by all PasswordHash classes. And moreover, I don't even need to instantiate PasswordHash in order to use the static method. I'll show you what this means in a bit. So this is going to be to hash sync. Okay, this is our first static method, and this is going to return a string. So just for the sake of, I don't know why it's giving me this error, maybe it just didn't realize that I wanted to change to a string. And yeah, maybe if I close the file and open it again, it goes away. Ah no, now I need to return, right? I need to return a string, yeah. So for example, if I have this password hash here, I can now come to the user model, and I will, let's say, add a new pre-save hook. So I'm going to say, okay, before you save this document, execute another function, not only the function to test for uniqueness of our password, but another function. So let's write this async function hash password, right? And this allows me to use the this keyword, and I can have the next function. And oops, that is not an arrow function. And for the sake of simplicity, I will just call this next. But what I can do here, maybe let me just say something, validate uniqueness, right? Maybe this will also go to a shared folder, but because this is a very authentication specific functionality, then this will probably stay within the auth service. I don't think it makes sense for us to put everything in the shared package. We need to think carefully what's going to be there, because if it's something that's specific to a service, then it makes sense to leave it within the service. But what I want to show you is that now I can have this password hash, which is going to be automatically imported here. Maybe I can even create an index file where I'm going to export it, right? Export default as password hash from .password hash. It will complain because there is no default there. So I come to the password hash and I make my export of my class a default export. Why am I doing that? Well, because the default export, at least from my perspective, it's normally the most important export in a certain file or module. And the named exports will be those exports such as types or interfaces, maybe helper functions, but it's just a convention. It doesn't need to be like this. It is, if you prefer to always do named exports, it's also not a problem. But the interesting thing is that I can come to the PasswordHash class and I can call directly the method toHashSync, and it's not going to complain, even though this is not an instance of that class. But because the method is static, I don't need to have an instance because the method will be the same for all the instances. So I can directly reference the class, right? So what I want to do is I want to go back to my password hash now that you understand a little bit more how it works, and I want to implement this toHashSync. Why am I writing the toHashSync? Well, in the previous video I briefly mentioned that by default script that or a script that we are going to use here, right, a script from crypto, by default this is an async function which is going to which can, let's say, if we want to encrypt multiple objects, we can fire, let's say, 10 of this and do a await promise.all. So they will somehow run in parallel. If there is really parallelism implemented, they can run in parallel and we don't need to wait to run sequentially. We can run them in parallel. But for our purposes, we really need to have the hashed password before saving the user to the database. It cannot be something like, oh, okay, start the process of hashing the password, give me the promise, I'm going to start the promise. Once the promise resolves, I'm going to go to the database and I'm going to update with the result, right? Doesn't make sense. So for us here, we really need to have the result so we can use the synchronous function. So another thing that I need here is a random bytes. And why do I need a random bytes? Because this is going to be used to define the salt of my hashing mechanism. What is the salt? Well, that is more to the theoretical side of password hashing and encryption using a script or bcrypt or any other algorithm that you know that you prefer. All of them are equally secure and there is no clear winner when it comes to this. So we'll go with a script, and that's because it's designed specially to make brute force attacks hard and expensive, right? So that's pretty much what we want when we talk about passwords. So when I want to hash something, I need some arguments, right? What do I need here? Well, here I need just a password, and the password is a string. Now, personally speaking, I tend to avoid directly writing the parameters in our function parameters. I'm not very fond of making a structure like this. arg0 is a string, arg1 is a string, arg2 is a string. I don't like it that much because, as you can see, if the names are not clear, it's very easy to mess up, right? The order, I mean, if I'm calling the toHashSync, let's say that's the password, and I'm having some other function that's going to provide some salt for us here already created. It's a dedicated function for the salt, and then I have another function that is going to provide us some I don't know, reminder or some key from the environment. I don't know, just thinking about something. If I mess up the order of whenever I call this toHashSync and I pass, let's say, arg2 instead of arg1 and arg1 instead of arg2, if I don't have very good names, there is no way for me to know that I'm messing up the order, except for the bugs that this will create. So what I prefer to do is I normally go with declaring or exporting a clear type, and that's going to be a password hash to hash sync, right? That's the name of my function, args. and this will define all the args of my function. So all I need is a password. So here what I can do now is I can delete all of this, and I can say args is of type PasswordHash to hash sync args. And this allows me then in the future to actually reference the arguments by using destruction, right? By destructuring the arguments into its components, because it's an object. So here I can retrieve my password. The benefit of this is that I can have a password, let's say an email here, something like this, and I can pass them in whatever order. If the object from the parent or from the function, from the class that is calling this function, or from the method that is calling this function, if they pass in this order or in the previous order with email below, it doesn't matter. In the end, email and password will be retrieved by their names. And if I want to extend, or if I want to remove some keys from here, for example, if I want to extend this and add a new functionality, let's say email, a string, right? And I mark this as optional, this is not going to break any code that already implements just the password, right? Because email is optional. So it's also good if you want to introduce changes without breaking your current code. So it's just a personal approach. Let's then calculate the salt. How do we calculate the salt? The salt is simply a random bytes of 16 to string of hexadecimal with an encoding of hexadecimal. That's nothing more than the salt, right? The salt is a string of random bytes of size of 16 bytes transformed to a string of hexadecimal. Maybe you want to use another, but for our purposes hexadecimal is enough. And then we have the buffer, which the buffer is going to be nothing more than a script sync with the provided password, the salt, and the key length. This is normally taken to be at least 64, and then we can return here not a simple string but a backticks with the buffer that is going to be to string, again in a hexadecimal format, dot our salt. And this salt is going to be used later on for, oops, I think I'm putting this somewhere wrong, it should be here. This is going to be used later on for comparing the passwords, right? So now I have a export default class PasswordHash that I can call the toHash sync by passing the password. And if I come here now in my user, as you can see, it is already complaining that the PasswordHash is not being called with the necessary parameters, right? So one thing that I want us to do is, instead of always hashing the password, because if the password didn't change, it doesn't make sense to hash it, right? So what I can do is I can call if, and then this dot is modified, and this allows us to check if any field of the document has been modified since the last time that it was in the database. So if this dot is modified password is true, then I enter here, and then I have my hashed password, and this is going to be equal to my password hash, and here I'm going to pass as a password the this.get, and this is going to allow me to get the password field, and this is going to then have the hashed password in this string. Now I'm going to have this.set. So the get and the set are two methods from Mongoose that I can use to both to respectively get the values and set the values of certain fields, certain keys, or certain attributes in my user model. So now that should be, let's see what's going to happen to our tests. Maybe this is all that we need for our tests to pass, or maybe we need something else. Let's see. No, that's all we need. So now both the sign up route, maybe I can open it here. Where is it in my routes? In the sign up file. And just to just to tell you, of course, this all is going to change maybe in the future. We'll do some refactoring, extract this to its own middlewares. But for now, it's enough to be in the body of this function, right? I mean, later on, when we talk a little bit more about code quality, then maybe we do some refactoring here. But I do think that we are trying to follow the structure, or at least implement some good practices already with the custom errors, or with the custom, the try catch statements and everything that is already working here with the customized error handler middleware. So we are already implementing some good practices, but there is still space for improvement. But just to tell you, the sign-up route is encrypting the password whenever I create the user here, right? Then it goes to the user model. It calls this pre-save hook, and it hashes the password and saves the password. So what I would like to do now is to go a little bit beyond, and within my password and within my user maybe, right? So within my user model, what I would like to do is I would like to write a couple of tests, and I would like to test that when I compare the password, so the hashed password and the original password, they are the same, right? After doing exactly these tests here. Because we are already in 21 minutes, let's postpone this to the next video, and we will be right back with this. So let's split the work here, and we continue in the next video with this final test and the final method in our password hash class to compare two passwords. Thank you very much, and see you in the next video. Bye bye.